Hi and welcome. My name is Abdelaziz Gazel. In this video I'm going to show you how to configure Igrt and BGP, the Internet Protocol, or as well known Border Gateway Protocol. In this scenario right here we have a corporate company, which is this one right here, that have two routers and they are connected to two ISPs. We assume that this company actually they are more dependent on the internet connection for some reason. Maybe they are running e-business and they want access of the internet users into their e-business servers and web servers, right? I already configured the IP addresses on all routers right here, just for to make this video as short as I can. So, and I already yeah, the IP addresses only. So I want to check the connectivity of the IP addresses between these two routers right here and between these two and these two, so each can reach each other through ping. So let's do it. Okay, we're on ISP1 as you see here, and we are going to ping C1 router. Okay, our IP addresses are configured correctly since we can ping this router right here from the ISP1. Let's go to C1 actually and do a ping to C2, which has an IP address of 10.1.1.2, and sure enough we can ping it. Let's ping it from the other link. I have configured these two links, redundant links, in the company for a reason. Okay, let's do it, and it's 10.2.2.2, right? We can ping it, and let's go to ISP2 and do a ping to C2, which has the IP address of 192.168.168.1.2, and sure enough we can ping it. Now let's begin the configuration of Igrt between these two routers in the corporate company, because we need to configure IBGP inside the company. We need to reach this loopback interfaces, and by the way, we use loopback interfaces because if we have if we use a physical interfaces on these two routers and one physical interface goes down, the neighbor relationship between these two routers will go down also. So loopback interface is better and to improve performance, and also loopback stays up and always up since router have at least one physical interface up. Okay, anyway, now we need to configure Igrt. Let's hop to C1 router and configure Igrt. Let's give it process number 100, and okay, and we want actually to advertise network. Before we do that, let's check IP show IP interface brief. Okay, we are connected to this router right here with these two interfaces through serial 01 and serial 02, right? So 10.0.0.0, okay, and network of the loopback address, which is 192.168.2.2. okay. Cool. We advertise the 10 network. Okay, we have a okay, summarizing, and I can see that the auto summarization is in effect. As you see here, you know, Cisco states that since the iOS 12.2.8t, it's disabled by default, but as you see here, it's on, it's still on. So let's do show version. I just want to show you that this version is 12.4 right here, but we still have to disable the automatic summarization. So no auto. Okay, cool. IP protocols. Okay, here we go. Automatic network summarization is not in effect, and we're advertising these two networks, 10 to establish neighbor relationship on this link, and also to advertise loopback interface to be reachable through this router. Right, let's go to router 2 and do the same thing. Router Igrt actually 100, and network, which will be 10.0.0.0, and network, which is 192.168.3.3.0.0.0, okay, and no auto summary. Remember to turn off the auto summary. To show IP protocol, as you may see here, the neighbor has come up, two neighbors, you know. Show IP protocols to verify. We are running process number 100, and we are advertising 10 network and 192.168.3.3, which is loopback interface. Let's check the routing table right now. In the routing table we have 192.2.2 right here, learned via IGRP. So at that point we can ping it. Do just to be sure that we can ping loopback interface on router 1 on C1 router. Sure enough, we can ping it, and we are good to go. Actually, at this point we are ready to run the IBGP between the routers inside our company, and let's do it. Okay. Before we do that, let's check if we could reach the ping. We could reach the loopback interface on a router on C2 router, and sure enough we can ping it. Exit router BGP. As you may see here, we have the local autonomous system number, which is 500. Okay, that's all to turn it on, and you will need to add a neighbor command, which is neighbor followed by the IP address of the neighbor that you want to establish a relationship with. Our neighbor actually is C2, right? So the IP address of C2, which is loopback address right here, which is 192.168.3.3, okay, followed by remote IS, which is the same local IS, right? Because this is IGP. And by the way, when you type the remote IS and you put the same IS as a local, the process of BGP knows that this is internal BGP, which is called briefly IBGP. Okay, at this point we are establishing a neighbor relationship. So this router right here is trying to send an open message and establish a TCP connection to this router right here. Let's hop to router C2 and mirror the configuration of IBGP 500 and neighbor, which is 192.168.2.2 and remote IS, excuse me, 500. Right, let's check. Show IP BGP. Nothing. Why? Simply because BGP is different than the IGPs, OSPF, RIP, and the IGRP, and so on. So the neighbor command is just to establish a neighbor relationship, tells the router where to send the advertised route, doesn't advertise any route at that point. So IPBGP, the BGP table is still empty, there is nothing in it. Let's check neighbor relationship to show IP BGP summary. We have a neighbor which is 192.168.2.2, which is C1 router, version of BGP which is version 4, the IS autonomous system number 500, received message none and 00. I want to see this active. If you remember the active state from OSPF and EIGRP, active is bad, and the router now is actively trying to establish a TCP connection, but it will stay active or idle or connect between these two states. Okay, and to fix this problem, the problem is now this router right here is sending an open message to this router, but the source that is using either 10.1.1.1 or 10.2.2.2 IP address, not using loopback interface. But this router gets the message, the open message, check it, and find out that the source address is unknown for him, because he has a neighbor established with the IP address of 192.168.3.3, not 10. So to fix this problem, we need to add a command which is a neighbor and the IP address of our neighbor, which is 192.168.2.2, followed by update source and loopback 0. So at that point we are telling the router to send an open message from the loopback interface. So when router 1 gets it, or C1 router gets it, he will know this IP address, and it's the IP address that is configured on neighbor command, right? We need to do it also on C1 router. Neighbor command and the IP address of loopback interface on C2, and update source loopback interface 0. And we need to wait a little bit because BGP is the most slower routing protocol ever. Yes, here we go. The neighbor has come up and we can see 0, meaning prefixes right here, and messages are sent and received. 2 messages sent and 2 messages received from our neighbor. So let's do show IPBGP. As I mentioned before, there is no routes in the IPBGP table, okay, simply because we are not yet advertising any route into IBGP. Okay, So next point, I want to advertise route into IBGP. Before we do that, let's check C2 router to show IPBGP summary, and sure enough we don't have any prefixes on it. So let's hop back to C1 router and do a network command, and that's the command to advertise a network. There is two ways to advertise network into IBGP, either using network command followed by the network that you want to advertise and the mask. And by the way, the mask need to match the exact subnet mask that you are using when you are configuring that interface, and also the network that you are advertising need to be in the routing table. If it doesn't exist, you need to create or send it to null 0. I will show you after a while how to do this. So let's advertise, let's do show IP, show, let's check in the routing table, IP route, and we have actually this IP address right here, directly connected to loopback 1. Okay. Network command, which is 192.168.15.1 actually, .0 255.255.255.0. Sorry, I forget the mask keyword. Mask and here we go. To show IP route, to show IP BGP. Yes, IP BGP. We are advertising this network, and next hop is itself, this router itself, right? Actually, the weight, the route that is originated by the router have the weight of 32,768 by default, and as you see here, path is I, which is internal, okay, because it's configured by the network command. The star here means a valid route, and the arrow here next to the IP address meaning is best meaning that this route is installed in the routing table. Let's hop to router 2 and check. To show IP BGP, sure enough we have that route advertised, right? 192.168.15.0, and next hop, which is 192.168.2.2, which is the loopback interface on router C2. Okay. That's how to do it in this way. You can do it also, you can advertise by using a redistribution command. Redistribution command with route filtering, like route map, distributed list, you know. First you need to create an access list and, you know, put it in a route map and then advertise that route map. Okay. Cool. Now we need to set up eBGP between these two peers right here. Let's go on, since we are on router 2 right now, let's configure eBGP between these two peers right here. Okay, the local autonomous system number and neighbor, which is 192.168.1.1. Neighbor, sorry, remote IS, which is 200. Right? At this point we are sending an open message to this neighbor but the neighbor need to be configured also to exchange TCP sessions and establish a neighbor relationship. Router BGP and local autonomous system number, which is 200, and our neighbor, which is 192.168.1.2, right? .0 neighbor. And I'm so sorry about that, because I'm just going with the configured an IP address. The remote IS is actually 500. The remote IS of this router right here. Let's check to show IP BGP. Nothing. To show IP BGP summary, and we are still in active state. We are still in active state. Okay, let's check. Give it time. We are still active state. Neighbor has come up. I told you, you know, that BGP is a slow protocol now. Let's do it again, and we have a prefix list. This router here has received the advertised route from router C1 right now. Let's check it. IP BGP, and here we go. We advertise this route right here, and this router is automatically receive this route. But look at the next top IP address, 192.168.1.2, which is this interface right here. Cool. Go this way, right? I want to mention one thing, which is a next hop rule. Since we are advertising from IBGP into EBGP, EBGP actually does change the next hop IP address in like IBGP. If we advertise some route from the ISP2 into this C2 router, and C2 router will advertise this route into IBGP, IBGP will still have the same next hop IP address, meaning that this router will have a route to some network right here, but with this next hop right here. And that's an issue, and to fix it you need to issue the command next hop self neighbor. I will show you how to do it after a while. Now our neighbor relationship between these two routers are formed. Let's hop to ISP1 and configure neighbor relationship. To show IP protocol, I just want to know that there is no protocol configured right there. So router BGP and the local autonomous system, which is 100, and neighbor neighbor followed by the IP address of C1 router 16.1.1, right? Oh my god, I'm always, you know, forgetting both the mask command. Okay, mask, come on, remote IS, remote IS, which is this autonomous system number right here, 500. We are sending TCP open TCP session to this router right here, or open message, right? And we need to do the same configuration on C1 router at that point. Let's do, actually we are on router BGP. Let's do it again just to be sure. That's and neighbor 172.16.1.2. okay, and remote IS, which is 100, right, to show IP BGP summary, check neighbor relationship between these two routers, and as you see, it's still active. Active is bad, just remember that. It will go from active to connect and idle and stays between these three states is not bad. A neighbor has come up right now. It takes sometimes 60 seconds. It's so slow. I meant it when I said it's so slow. Alright, let's check now. Summary, and we have neighbor but no prefixes yet has learned. Okay. What is the problem right now? We cannot see. We have a neighbor which is 172.16.1.2, and we have this neighbor right here which is C2, and we have this neighbor which is the ISP, our ISP. If we will go to our ISP1 and check if we have this route, show IP BGP, yes, we learned this route via 172.16.1.1, and there is no problem at this point because eBGP does change the next hop IP address. At this point we can reach this advertised route. Let's do a ping to 192.168.15.1, and sure enough we can ping it, right? As I promised before, I want to show you how IBGP or eBGP right here, eBGP, okay, and here we have IBGP, which is internal to this corporate network right here. I will go to, let's go to ISP1, right, and let's do an interface. Let's do an exit. Let's add a loopback. Let's check. Okay, we have no loopbacks configured on this router. Let's start with loopback 0 and give it an IP address. And the IP address that we will give it, so let's say 172.17.1.1. okay, or let's do it like let's go public, right? That's 1.1.1, and it's already there. Check. Okay, we have this interface right here, and what I want to do it with redistribution, since we did it in this scenario, you know, with network command. I want to show you how to do it with redistribution. We'll go to router BGP local IS 100, and we want to redistribute connected. But before we do that, we don't want to advertise the WAN link into the corporate network, right? So what we need to do, we need to create an access list and link it to a route map. Okay, let's do an exit. Let's do an access list. Okay, access list, let's one, and permit 200.1.1.0, okay, 255. This is wildcard mask that tells the router to check this, check this, check this. I don't care, right? Meaning that allow any IP address that starts with 200.1.1, okay, and enter. Now let's create a route map. and give it name filter. And it's a good thing, you know, to do capital letter in like access list name, roadmap name. You know, it's good to see it and recognize that you configure it, that you made it. You know, you entered this name. It's not something related to the iOS, so it's a good thing to do. Roadmap filter permit, okay, permit, and sequence number 10, match IP address, okay, in the access list 1, right? Match the access list number 1. Remember that when we configure this access list, permit this subnet with this wildcard mask, there is an implicit deny always in the end of the access list, right? So we are permitting this and denying this WAN link with any IP address, okay? So at that point, let's check our access list to show IP access list or show access list. Okay, let's verify roadmap. Okay, roadmap says here roadmap named filter permit sequence 10. By default, if you don't specify a sequence number, it will start with number 10. Match clauses match this IP address that is in the access list number 1, which is right here. Okay, access list, where is the access list actually? Anyway, access list, yeah, right here, the IP address in the access list, okay, and I think we're good to go. Let's configure the distribution route or rather BGP 100, and to configure or to redistribute a route into BGP redistribute command, redistribute connected. Redistribute connected will advertise all connected interfaces on the router. Remember that. So we create a route map to prevent router from advertising the WAN link. We don't want our customers to see our WAN link IP address or whatever. Okay, and followed by route map. Route map, we name it filter. It's case sensitive, and be sure to check the name. I would prefer to highlight it and copy paste, and here we go. Now to show IP BGP, cool, self. We are advertising this network right here, okay, and next top is a self. If we will go to C1 router and check the routing table to show IP BGP or BGP table, we have learned about this network right here. Next top 172.16.1.2, okay, to go 1.2, which is this interface right here. At this point we are good. Let's check on C2 to show IP BGP, okay. See the problem that I mentioned before. We are learning this network that we advertise from this router right here, and see next hop address is actually this interface, but this router doesn't know how to reach the next hop interface of this router right here, right? So I think we are having problem at this point, you know. If we will do ping the next hop, we will not reach it. 16.1.2, right? We cannot reach it. We can either advertise this network along with this interface, or we can use some static route or some complex things, but to fix this issue is very simple. So what you need to do is to go into this router and tell the router that advertise IBGP route and use next hop your IP address as next hop. So if the C2 want to reach a network, in IS 100 or beyond, he needs to use next hop IP address, which will be loopback interface on C2, right? Or self. Let's do it. Let's go on router 1 and tell him to do that. Neighbor, and the IP address of our neighbor, which is 192.168.2.2. okay, and followed by next hop self, and that's it. Check now. You remember that we learned the route, okay, on this interface. See now, okay, we learned this route, and next hop is set to 172.16.1.2, which is this interface on ISP1 right here. Check now. When we enter this command, cannot configure local system as a neighbor, I think we are doing something wrong, because we are actually yes, we did wrong. Neighbor 192, I meant the neighbor C2 dot 3.3, right? And next hop will be self, okay, self, okay, to show run. By the way, this is cool command, to check the BGP configuration or IGRP, or section followed by the protocol that you're using or you want to check. Actually, we have the command entered here correctly. Now let's hop to router 2 and check if the router 2 is still pointing to next hop of the ISP1, or change his mind to show IP BGP. Look at that. See that, man? Now is pointing to router 1, to C1 router, right? And that's how it should be. And let's do ping now. Let's verify reachability to C2 to ISP1. Do ping 200.1.1.0. No. What's the problem actually? No. Yes. I know why. Let's actually hop to ISP1 and check if we could reach this router right here to show IP route. Okay, we have a BGP right here, and sure we can ping it. Do ping this right here. Okay, .1. Sure enough, we can ping it. And what we need to do is go to router C and advertise its loopback interface, right? Let's check if the loopback is not configured, is not advertised. Run section BGP. No, we are not advertising any routes on this router right here, and let's do it. Network 192.168.3.3. 3.3 and mask with a mask of 255.255.255.255, which is a host. I don't know if you have been doing that before, because this is the host subnet mask. Right, now we are advertising the loopback interface of C2 router to show IP BGP table. Okay, yes, we are advertising it, and let's hop to ISP1 to show IP BGP. Yes, we are learning that interface right here, and let's do ping it. Okay, 3.3. No, we cannot ping it. 192.168.3.3/32. Actually, next hop IP address, which is 172.16.1.1, which is this interface right here. Yes. What is the problem, man? What is the problem? I will stop recording and check the problem, and I will come back again. I hope that have been informative for you, and thank you for